Hello and welcome to this summarization of the book The Art of Statistics: How to Learn from Data from David Spiegelhalter. In this book you will get a better understanding of what the data is truly telling us. For example, if you want to discover how popular a politician is, you should look at her polling data. Or when you are unsure about the nutritional value of certain items, you turn to scientific studies that are backed up by mathematical evidence. It makes no difference if the subject is politics or nutrition. Statistics are based on numerical data, and numerical data is based on objective truths. In this case, statistics are the most objective measure available. As a result, statistics have no motive, they don't lie, and they have no ability to sway your view. At least that's our perception of them. However, the difficulty is that statistics are no longer considered to be a strictly scientific instrument as they were in the past. In today's world, practically anybody may gain access to data and begin analyzing it. As a result, it is feasible for nearly anybody to generate statistical graphs that appear to give supposedly objective data in support of an assertion. The use of statistics by politicians, advertisers, and the news media to support their viewpoints and beliefs has increased dramatically in recent years. As a result, statistics are increasingly being used for persuasive purposes rather than illuminating purposes. And statistics are gradually drifting away from strictly scientific procedures. Therein lies their value. They teach you how to more effectively evaluate all of the statistical assertions that have crept into our everyday lives. In addition, you will learn how to use statistics to find serial killers, or whether drinking one glass of wine is healthy for your health or not, and what extraordinary species responds to human emotions even after it has been dead for years. Statistics assist us in comprehending the world. Have you ever been curious about what professional statisticians truly do for a living? For many, statistics is just another dry subject of mathematics that is made a bit more interesting by the use of visual aids such as charts and graphs. However, mathematics is now simply one of many components that make up the subject of statistics. Today's statisticians deal with data over its full life cycle. This is typically divided into 5 phases: problem, plan, data, analysis, and conclusion, abbreviated as PPDAS. As a result, a statistician's responsibilities include identifying an issue, developing a strategy to address the problem, collecting relevant data, conducting an analysis, and formulating an appropriate conclusion. In the case of British serial murderer Harold Shipman, for example, the author was previously involved in a statistical crime investigation, and this case may be used to demonstrate how this procedure works. In fact, Shipman was a doctor, and the majority of his victims were elderly patients who were administered with a deadly amount of morphine by the doctor. He then manipulated her medical records in order to make her death appear to have occurred naturally. In total, by the time Harold Shipman was apprehended in 1998, he had killed at least 215 individuals in this manner, making him the most prolific serial murderer in British history. The author was a participant in the public investigation into whether Shipman's killing may have been uncovered earlier if more people had known about them. As a result, this query served as a jumping off point for the statistical determination, the problem. The following step, the plan, consisted of gathering information on Shipman's patients and comparing it to information on other deceased patients in the vicinity. The statisticians wanted to see whether there were any strange disparities between the two datasets, so they ran some tests. The strategy was put into action and the necessary data was gathered during the 3rd phase of the process cycle. In this case, hundreds of physical death certificates dating back to 1977 and up to the time of Shipman's arrest were reviewed. The data was examined in the fourth phase, which involved feeding it into software and comparing it with visuals. Two items were discovered as a result of the investigation. First and foremost, Shipman's documented fatalities were significantly higher than the norm for his geographic area. Second, the fatalities at the other practices occurred throughout the day, but Shipman's victims died primarily between 1 p.m. and 5 p.m., which coincided with the hours that Shipman conducted home visits in his neighborhood. The following was the final conclusion. In the author's study, it is suggested that Shipman's murders have been detected based on the available data as early as 1984, 15 years earlier, and this could have spared up to 175 lives. As a result, statisticians are responsible for identifying patterns in data in order to address real-world issues. Data are frequently skewed in a predictable manner. While it may appear that data are infallible facts at first glance, they are vulnerable to human prejudice and mistake, just as any other type of knowledge is, and hence are not infallible. It is true that our imperfect human judgment enters the picture even before we begin collecting the facts. Before we can begin collecting data, we must frequently make arbitrary judgments about what we want to measure and how we want to assess it. We must first define what exactly constitutes an animal before we can establish how many animals there are in the world, as an example. It's not that simple to make a decision. As a result, most studies only include animals that is at least 1 centimeter long in their findings. As a result, data might get skewed if our measurement criteria changes in the middle of the measurement process. For example, between 2014 and 2017, the number of sex offenses reported to the police in the United Kingdom more than quadrupled, rising from 64,000 to 121,000 incidents, according to the police. According to reports, the crime rate has suddenly risen dramatically. However, the underlying explanation for the increase is that sex offenses have been treated more seriously and documented more frequently since 2014, following the publication of an investigative report that questioned police recording practices. To avoid being misled into thinking that data is an entirely true depiction of our world, we should never believe it to be such. A great deal of information is gathered through surveys in which people rank their own personal experiences. Participants are then asked to rate their level of happiness on a scale ranging from 1 to 5 on a variety of topics. However, such reduced surveys will never be able to capture the complete spectrum of human experience. Furthermore, the way in which people comprehend and answer questions varies from person to person. As a result, one of the most difficult aspects of statistics is the formulation of the questions. The way we think about a topic can be greatly influenced by the language we choose. Participants in the British research, for example, were asked what they felt of granting 16 and 17-year-olds the right to vote. The results were mixed. It received support from 52% of those who voted. Afterwards, when the same respondents were asked the same question, this time about their opinion of the reduction of the voting age from 18 to 16, just 37% said they were in favor. Sometimes it is not the question themselves, but the alternative replies that cause the statistics to be distorted. For the first time, Ryanair claimed that 92% of its clients were pleased with their service in 2017. Soon after, it was discovered that the relevant customer satisfaction survey only permitted the responses excellent, very good, fair, and alright. This was quickly corrected. Consequently, statisticians frequently have to deal with inaccurate information before they can even begin to examine the data. The manner in which data is presented has an impact on our understanding. In recent years, there has been an increase in the discipline of data visualization. of statistical results. Data visualization are graphical tools that make data accessible while also communicating statistical information to the viewer or listener. Such representations are referred to as interocular by statisticians because the patterns in the data may be observed with the naked eye without the need to perform a great deal of mental math. A bar chart comparing the mortality rate after cardiac surgery at several hospitals is one example of this. Identifying which hospitals are significantly different from the norm may be done quickly and readily without having to consult the figures. Accurate and effective visuals, on the other hand, need meticulous planning. Color, typeface, organization, and language all have an impact on our interpretation of the facts. As a result, statisticians and psychologists are now collaborating closely to investigate how various graphs impact our comprehension. Let us return to our hospital example and suppose a statistician who wishes to give mortality rate statistics in the form of a spreadsheet to the staff. First and foremost, she must choose which hospitals should be included in which order. At first glance, ranking hospital according to their mortality rates may appear reasonable. However, there is a risk that this ranking may convey the idea that hospitals are being ordered according to their quality, which is incorrect. The top hospitals, on the other hand, have greater death rates than the rest of the country because they handle the most critical cases. The framing effect is another manner in which our understanding might be influenced by the way a presentation is presented. The emotional effect of a statistical claim is influenced by how we frame it. A few years ago, an advertising campaign on the London Underground reminded people that 99% of young Londoners do not commit severe crimes, a statistic that was emphasized in the campaign. A sense of security for Londoners was most likely intended by this. However, if the figure were stated as follows: 1% of young Londoners commit major crime, the emotional impact of that assertion might readily be reversed. That has a more foreboding ring to it. There are 10,000 juvenile offenders in London, says the author, when he refers to the actual number of offenders rather than the proportion of offenders. Statistics brokers frequently employ framing to their advantage, depending on whether they are attempting to shock or comfort their target audience. Researchers must thus pay close attention to the clarity of their terminology in order to avoid unwarranted emotional reactions to data. Selective reporting frequently causes data to be skewed in favor of the positive. Many scholars spend their entire lives sifting through data in quest of breakthrough discoveries that they almost never come upon. Some researchers are under pressure to publish crucial new findings, which causes them to gift a little portion of the data. Some scientists, despite the fact that they should be devoted to the truth, adopt dubious research methods as a result of this. Multiple testing is one such technique, in which the researcher repeats his or her experiments until they achieve the desired result. The more the number of times he tests, the greater the likelihood that he may have a false positive result. False positives are outcomes that appear to support a hypothesis, but are actually the consequence of random mistake in the data collection and analysis. In 2009, a study was undertaken by a group of respectable researchers that brought this issue to light. They employed an imaging technology to evaluate the brain activity of a participant who was looking at photographs of various human emotional expressions while the images were being viewed. What's the catch? The subject in question was a 2-kilogram Atlantic salmon that had died. Only 16 of the 8,064 locations assessed in the fish's brain responded actively to the pictures, indicating that the rest were inactive. The researchers, on the other hand, did not come to the conclusion that deceased salmon possess mystical abilities. As an alternative, they wished to demonstrate that with over 8,000 tests, it is inevitable that some may be false positives. False positives, on the other hand, are frequently the ones that make the headlines. Even science periodicals in general are only interested in publishing discoveries that are engaging and significant. This leads to a positive bias in the scientific literature, since the general audiences only sees research that support a theory, rather than studies that do not support a hypothesis. This, in return, has an impact on how the results are interpreted. You would be understandably concerned if you learned about a research concluding that eating bacon increased the chance of developing cancer. However, if you also knew that 20 other studies had found no link at all between excess fat and cancer, the emotional impact would be drastically lessened even more. The factors that lead to such selective reporting are numerous and complicated. In addition, they must cope with excessive academic pressure as well as human sensationalism. The ensuing bias is so large that John Ioannidis, a statistics professor at Stanford University, once observed that the vast majority of published research is incorrect. Despite the fact that Ioannidis was clearly attempting to elicit a response with his comment, it can serve as a valuable reminder that scientifically published study results should not be taken as indisputable facts. The media is more concerned with compelling stories than with statistical truth. Once a study has been published in a peer-reviewed journal, it can be covered by the news media. They do, however, frequently use a great deal of artistic license, much to the dismay of scientists. The good news is that data journalism is becoming increasingly popular. Information is increasingly being interpreted and communicated by journalists who are becoming more adept at doing it. Furthermore, statistics may significantly enhance the quality of media coverage by giving data and linkages to critical themes. However, there's always the possibility that the journalist would exaggerate a statistical figure in order to tell a more engaging tale. Good tales frequently necessitate the inclusion of an emotional compellent that is absent from scientific investigations. This has resulted in news platforms and online publications processing sophisticated information into dramatic and completely deceptive headlines, since they are more interested with social media traffic than with actual science. Once, during a presentation, the author made a rash statement that launched him right into the midst of a fascinating narrative. During the lecture, the results of a public poll on the sexual habits of the British people were discussed. According to the findings of the survey, young people in the United Kingdom are having 20% less sex now than they were a decade ago. The author hypothesized that the development of streaming services such as Netflix was to blame for the fall in sales. He then fueled the British media with titles such as "Lonely Scientist claims Netflix will replace sex by 2030, which was based on his reckless prediction. With the exception of such plainly vivid fantasy stories, the media frequently achieves the emotional effect they want by inflating a statistical danger. When a World Health Organization research indicates that frequent meat intake elevated the risk of colon cancer by 18%, the news media focused heavily on the 18% increase in the risk. And to be honest, this figure appears to be somewhat frightening at first. The majority of media coverage, on the other hand, conveniently failed to discern between relative and absolute danger. The 18% greater risk of colon cancer among meat eaters was a relative risk. It was compared to the 6% increased risk of colon cancer among persons who did not consume meat on a daily basis. The risk of colorectal cancer increases by 18% in the 6%, resulting in an absolute risk of 7.08%. Meat eaters are just 1% more likely than non-meat eaters to get bowel cancer, according to the American Cancer Society. That appears to be less frightening. Exaggeration or concealment of such risk levels, on the other hand, is merely one of many mistakes in statistical interpretation committed by the news media. Here is another example. Respondents to a sex survey in the United Kingdom were asked to report the number of past sex partners they had. The most often reported number of sexual partners was 1, according to the data. The vast majority of participants reported having between 0 and 20 sexual partners. In addition, a minority claimed numbers ranging from 20 to 500. Because of this minority who reported numbers considerably in excess of 20, the mean number of sexual partners for this dataset is significantly higher than the average number of sexual partners reported by the majority. It would be inaccurate to use it in this context. The median, which is the number that falls in the middle of the dataset, would provide us with a figure that is more representative of the average person's experience. The mode in this example, the number 1, would provide us with insights about the most common experience we would have. The sort of average that is utilized in media coverage, on the other hand, is practically never mentioned. The sort of average that is utilized in media coverage, on the other hand, is practically never mentioned. The mean value, which is frequently unsuitable, is utilized in the vast majority of situations. It is for this reason that many of the statistics assertions we hear in the media are deceptive and contradictory with our own observations and those of other people. Every statistician knows that correlation does not imply causation. When it comes to statisticians, the expression correlation does not indicate causation has practically become a cliché. However, it cannot be emphasized enough how important it is. The reason is that both individuals and the media are consistently duped into believing that a relationship between two datasets automatically shows causality. And it is because of this misconception that ludicrous headlines such as "Why studying at university raises the risk of brain cancer" are written. According to the findings of the study on which this headline is based, those who have a higher degree of education are more likely to acquire brain tumors than those who do not. However, this does not imply that studying is a risk factor for brain cancer. It is speculated by the study's author that the association is due to some type of bias in the data gathering process. It's possible that those with higher educational levels may be more likely than others to be checked for brain tumors, and as a result will be more likely to acquire this diagnosis. Whenever there is a relationship between two sets of data, we should refrain from concluding that one component is responsible for the other. A data correlation can frequently be explained equally well by any one of the three alternatives. It is possible that two datasets are correlated just by chance, as demonstrated in this ridiculous example. Between the year 2000 and 2009, there was a significant relationship between per capita mozzarella consumption and the number of engineering PhDs conferred in the United States. Even yet, it would be a stretch to argue that an increase in cheese consumption has anything to do with an increase in the number of mechanical engineering students enrolled in college. Secondly, the underlying causal links that are revealed by data correlations are frequently unexpected and in some cases outright counterintuitive in their nature. Many research on the relationship between alcohol intake and health have found that those who do not drink have a higher chance of dying prematurely than persons who drink in moderation. And it is from such research that encouraging headlines such as "A glass of wine a day is excellent for your health" are derived. Scientists, on the other hand, believe that the mechanism of action is precisely the opposite. Unwell patients are more prone to avoid alcoholic beverages. Finally, the association might be consequence of an unseen third component that was not taken into account by the study, but has an impact on the other two variables. If you look at the association between ice cream sales and the risk of drowning, you can see that it is entirely attributable to favorable weather. As a result, correlation does not indicate causality in this case. The concept of probability is frequently misinterpreted. What is it about probability that so many people find so complex and counterintuitive? Perhaps this is due to the fact that probability is a difficult and confusing subject. Politicians, like the general public, have difficulty comprehending probability. For example, in 2012, 97 members of parliament in the United Kingdom were posed the following question: what is the likelihood of obtaining 2 heads if you toss a coin twice? Because 2 heads are one of 4 potential outcomes. The answer is 1/4 of the total. The question was incorrectly answered by the vast majority of legislators, 60 out of 97 members. The gambler's fallacy is yet another example of a typical probability fallacy. People frequently make enormous changes to their probability expectations as a result of recent occurrences. When the color black appears multiple times in a row when playing roulette, it is easy to acquire the sensation that the color red is steadily approaching. And true to its name, the gambler's fallacy generates a significant amount of revenue for casinos. There is no system that ensures that random events always lead to the most likely conclusion in every situation. However, one of the great beauties of statistics is that over time, random events have a tendency to become increasingly similar to predicted probability. Even if you are flipping a coin indefinitely, the probability of getting heads or tails would increase closer and closer to 50-50 with time. It is quite amazing that such consistency can arise from what appears to be chaos. In the same vein, unanticipated social situations exhibit surprising consistency. In chemical gases, the random movement of molecules guarantees that the physical qualities of the gas are uniform. In societies, the unexpected motions of millions of individuals ensure that the social features of the society are uniform. As a result, the figures on suicide are extremely stable from year to year. Statistical methods are analogues to social physics when they are properly used. It assists us in making trustworthy long-term forecasts about situations that appear to be unexpected. I hope you liked the summarization of the book, The Art of Statistics from David Spiegelhalter. If you did, please leave a like and subscribe to our channel. And again, thank you very much for watching.